So for number one, how much of a 2-in-9 dilution can be created with 140 milliliters of NS? So that 2-in-9 dilution is a 2-to-9 ratio. But remember, the 2 represents the serum, and the 9 represents the total solution. Neither one of those represents the saline, or the NS. So we need to rework that ratio. Now, do we want the amount, are we trying to find the amount of serum? No. We're trying to find how much of that dilution. So we're trying to find the total solution. So we want to keep the total solution. So we're going to keep the 9. So what we really want here is the ratio of saline to total solution. So how many parts of saline are there going to be? 7. Good. If there's 2 parts serum out of the 9, 9 minus 2 leaves us with 7 parts saline. So we have 140 milliliters. That represents the saline, NS. And we'll cross multiply and divide 9 times 140 divided by 7 to get the total solution of 180 milliliters. So we can create 180 milliliters of that 2-in-9 dilution. Any questions there? Number 2, what dilution is created by mixing 60 milliliters of serum with 180 milliliters of NS? Well, what we have there, of course, is serum to NS. Let's create that ratio, but we know that's not our dilution. That's 60 to 180. That can be reduced. Both of those can be divided by 60. 60 divided by 60 is 1. And 180 divided by 60 is 3. So we have a 1 to 3 ratio, but again, that's not the dilution. The dilution is serum to total. So we have 1 part serum. If we have 3 parts NS, how many total parts do we have? 4. 1 plus 3 makes 4 total parts. So that is a 1 in 4 dilution. Any questions there? Number 3, connecting our dilutions to our concentrations. What is the concentration of a solution created by a 1 in 5 dilution of blood and water? What that's saying is we have 1 in 5 dilution. 1 is the serum, in this case that's the blood. The 5 is the total solution, total parts of the solution. There are a couple of ways we could approach this. One way that we could approach this is simply find a percent. A percent is the serum out of total anyway. So if we let the total amount be 100, this is going to give us a percent. Cross, multiply, and divide. 1 times 100 is 100. Divided by 5 is 20. So 20 out of 100, or 20%. A 1 in 5 dilution creates a 20% concentration solution. Other way we could have gone about that is we could have used that concentration formula that says the amount of the active ingredient, or the amount of serum, is equal to the concentration times the total volume. Here we have 1 part serum equals the concentration times 5 parts total volume, and we could solve that for the concentration. Solve it by dividing both sides by 5. Get that 0.2 equals the concentration. Recall, the concentration is just the decimal form of a percent. So to turn it into a percent, move the decimal point 2 spots, it's 20%. Either one of those is too bad. It's actually a little more difficult going the other direction. If I ask you what dilution is required to create 25% solution. There's a couple of ways we could approach that as well. Just kind of the reverse of what we just did. 25% is 25 out of 100. Well, 25%, that 25 is representing the serum. And the 100 does represent the whole amount, or the total solution. We could just reduce that fraction, that ratio. 25%, 25 over 100 is just a ratio. In this case, both of those numbers divide by 25, giving us 1 in 4. Or alternatively, we could have used that concentration formula again. 25% means 0.25 concentration. Problem is, we don't have either of these numbers, the serum or the total volume. It's a little clumsier to work with. What we would have to do is just pick a number for one of them. I might pick 1 for the serum, and then solve for what the volume has to be. Now, in this case, it works out nicely because 1 divides by 0.25. If it doesn't, then it's a little bit uglier to deal with. So 1 divided by 0.25 is 4. So the volume is total volume is 4, the serum is 1. That is a 1 in 4 dilution. Much easier just to reduce the percentage as a fraction. That dilution. So were there any questions off the homework that I gave last time? For the other sites, you should have received your test back in the email. Again, if you can't see the inking, my grading on it, try to open it on a WITC computer. It should be there. For those of you in the classroom, I passed some of them out earlier. The rest of you, I'll get them to you on break. Remember, again, you can still do corrections on those. Redo the problems you got wrong, show your work, and you get up to half your points back. You are allowed to work with other students. You are allowed to ask me questions. Please just make sure you have them right when you turn them back in. I want you to, first of all, maximize the number of points you get, but I also want to make sure that you know you have the right process down. You know what it is. So we're going to continue with these dilutions a little bit today and kind of going on to the next step. For example, if we add 80 milliliters of NS to 120 milliliters of a 1 in to a 1 in 6 dilution. Find the new dilution created. So we had 120 milliliters of a 1 in 6 dilution. Adding 80 milliliters of NS to it. It would be helpful here to know how much serum and how much saline were in the original dilution. So we're going to start there. 1 in 6 dilution. Remember that 1 represents the serum. 6 represents the total solution. Well, the 120 milliliters also represents the total solution. Put 120 milliliters on bottom. We will cross multiply and divide. 1 times 120 divided by 6 gives us 20 milliliters. Is there anybody that has any questions on doing that cross multiplying and dividing to find that missing number? So we have 20 milliliters of serum. Now we could set up the ratio for saline to total if we wanted to, but to save time, we know that the amount of saline is just the total amount, 120 milliliters, minus the serum, 20 milliliters, giving us 100 milliliters of saline, NS. So we currently have 20 milliliters of serum, 100 milliliters of saline. We are about to add 80 milliliters of saline. So we now have a total 180 milliliters of saline. And still only 20 milliliters of serum. So to find our dilution, it's 20 milliliters of serum over 180 plus 20 milliliters of total solution. Notice we had to take the saline plus the serum to get the total. So that's 20 over 200. The milliliters cancel out. And those reduce. Both of those can be divided by 20. Becomes a 1 in 10 dilution. So where are the dilutions useful for us outside of that? Well, when you're trying to do blood testing, urine testing, and other testing, the meters have limits. So if blood sugar levels are over a certain level, the meter can't take that reading. So if we have a case where the level of blood sugar exceeds that limit, our options for testing pretty much are to find a different meter or to dilute the blood. So let's say that we have a case where that blood exceeds the meter's limits. So we perform a 1 in 4 dilution of that blood in a neutral solution, sterile water. After that dilution, we now test it, and the reading is 273 milligrams per deciliter. Milligrams per deciliter is the typical units for a blood test. Find the true reading. What is the true level in that blood? Well, we performed a 1 in 4 dilution. The reason we use dilutions the way we do, that it's serum to total rather than any other relationship, is when we do it that way, it has a definite relationship to these readings. This is the diluted reading. The concentrated reading, we would expect to have a higher level, a larger number, correct? So what the meter said, we expect to be smaller than what the actual level is. So we're going to put that number, the 273 milligrams per deciliter, with the smaller number in our dilution, the 1. And we'll cross multiply and divide. 4 times 273 divided by 1 gives us, what is that, 1,092 grams per deciliter. That is the true reading. That, by the way, is approaching comatose stuff. So that type of problem can be worded in several different ways or approached in several different ways. Let's say you have a 600 microliter sample of blood. And dilute it with 3 milliliters of NS. The diluted reading is let's go 191 milligrams per deciliter. Find the true level. So what do we have to figure out first here? What information do we need to adjust that reading to get to the true level? The diluted reading, true level, of course, is going to be the concentrated reading. In the last problem, what gave us the relationship between the diluted reading and the concentrated reading? Where did this 1/4 come from? It was dilution created. So the dilution ratio is what tells us the ratio between the diluted reading and the concentrated reading. So down here we need to find the dilution ratio. The dilution ratio, remember, is serum total. How much serum do we have? 600 microliters. Total, we have 3 milliliters plus 600 microliters of the blood. We have the saline and the serum together here. Of course, the issue we run into is the units are different. I either have to change all the microliters to milliliters or the milliliters to microliters. I'm going to go ahead and change my milliliters to microliters. 3 milliliters is how many microliters? Get from milli to micro, there's 1,000 microliters in a milliliter, so 3 milliliters, 3,000 microliters. Add that with the 600 microliters, you now have 3,600 microliters. Top, we have 600 microliters. Hasn't changed. Now that we have the units the same, cancel out the microliters. 600 over 3,600 reduces to 1 in 6. Perfect. It's a 1 in 6 dilution. So now we are going to use that 1 in 6 dilution to adjust the meter reading. The 191, is that going to go on top or bottom here in this ratio? It's on top. We expect that to be the smaller of the numbers. 191 milligrams per deciliter. We will cross multiply. 6, 191 divided by 1, which gives us 1144, 1146 per deciliter. Any questions on how we got that? Let's say we have,
And though you don't have to go back, or did it take it back to grams?
because once we get this dilution ratio,
Okay,
it's unitless.
okay,
So that could be 1 milligram to 6 milligrams, or 1 microliter, 1 milliliter to 6 milliliters, 1 microliter to 6 microliters. That's it. Once we have the same units here and they cancel out, it doesn't matter what the units are here as long as they're both the same.
okay.
So let's say we have 240 milliliters of 40% solution. What dilution required to reduce that to 10%? So to create the current levels here, we have 40% of a 240 milliliters of a 40% solution. So I'm going to find the amount of serum, because the amount of serum is equal to the concentration times the volume. 40% is 0.4 as a decimal, times our volume of 240 milliliters. .4 times 240 gives us 96 milliliters. So we currently have 96 milliliters of serum. We are not going to change the amount of serum. We are going to, when we perform a dilution, what we're adding is saline, NS, neutral solution. Doesn't change the amount of medication. So we need to know how much saline do we have to have here to get this to 10%. So we're going to use that same formula, or concentration formula, only we know the amount of serum. We're going to change our concentration to 10%, so that's 0.1 or 0.10. We want to know what that new volume is going to be. Well, if we divide by 0.10, that new volume has to be 960 milliliters. So we have to, with the 96 milliliters of serum, have 10% solution, we have to have a 96 milliliter total volume. Well, we started out, right now we have 240 milliliters of the 40%. What are we going to add to get it up to 960 milliliters? Oh, we're going to add saline, neutral solution. How much do we have to add? Difference between 960 and 240. We're adding 720 milliliters of saline. So in this dilution, the dilution ratio isn't just serum to total, it's concentrate to total. Our first substance isn't a pure substance, it's already a diluted substance. So in this case, our concentrate is the 40% solution. We had 240 milliliters of that. We're going to increase the volume to 960 milliliters. I should put milliliters. So the dilution that is required, milliliters cancel out, reduce both of those, divide by 240, give us a 1 in 4 dilution. Any questions on what I did there so far? Similar to that problem, we might have 200 milliliters of a 45% solution. Perform a 2 in 5 dilution. Find the new concentration. So we have 200 milliliters of a 45% solution. First thing I'm going to do is figure out what we had for serum and saline to begin with. So again, that serum equals concentration times volume times total volume. Concentration of 0.45 times the volume of 200 milliliters. Gives us 90 milliliters of serum. Of course, 90 milliliters of serum, subtract that from the 200. Gives us 110 milliliters of saline. That's what we started out with. We perform a 2 in 5 dilution here. In that 2 in 5 dilution, remember the 2 represents the concentrate. In other words, that's the 45% solution. 5 represents the total. We started out with 200 milliliters of that 45% solution. We started with 200 milliliters of the concentrate. So after the 2 in 5 dilution, cross multiply and divide, 5 times 200 is 1,000. Divided by 2 is 500. After that 2 in 5 dilution, we have 500 milliliters of total solution now. In that 500 milliliters, how much serum do we have? Add any serum? No. We still have 90 milliliters of serum. 90 milliliters of serum equals our new concentration times that new total volume of 500. Solve this concentration by dividing by 500. $90 divided by 500 is 0.18. So a concentration of 0.18 or 18%. New concentration of that solution is 18%. Now there is a definite relationship between the new percent, old percent, and the dilution performed. We performed 2 in 5 dilution. Percent went from 45% to 18%. The dilution ratio is equal to the ratio of the concentrations. We look back at this previous problem we did, we'll find the same thing. We performed a 1 in 4 dilution here. We went from 40%, so the old percent was 40%, to 10%. The ratio of the concentrations is equivalent to the dilution ratio. So I might ask, what dilution is needed to reduce 36% solution to 12%. We're going from 36% to 12%. Cancel out our percent symbol and reduce that dilution. Both 12 and 36 divided by 12. That reduces to 1 out of 3. So 1 out of 3 dilution, or 1 in 3 dilution is required to dilute a 36% solution to 12%. (24% solution) goes through a 3 and 8 dilution. Find the new concentration. So here we have a 3 and 8 dilution. (24% is the old percent that goes on bottom. Cross multiply and divide. 3 times 24 divided by 8 gives us percent. New solution is 9%. Any questions here? So let's say we're going to take the volume of a 24% solution is 200 milliliters and is increased to 600 milliliters by adding NS. Find the new concentration. So again, we have a dilution here, going from 200 milliliters to 600 milliliters. (200 milliliters was the volume of the concentrate. (600 is the total after the dilution. So that obviously reduces a 1 in 3 dilution. 24% is the old percent. Cross multiply and divide. Get percent. If you look at this formula closely, taking it back to this original ratio here, 200 milliliters represents the initial volume. I'm going to label that volume 1. That's the volume before the dilution. The 600 milliliters represents the volume after. I'm going to call that volume 2, V with a little subscript 2. On the other side of this, 1 to 3, the 1 represents the 8%. That is the concentration after the dilution, C2. 24% was the concentration before, C1. You'll notice V1 and C1 do not line up. This is what's called an inverse relationship. We'll talk about inverse and direct relationships a little bit more in Unit 4 when we get to it. But all it means is when one number gets larger, in this case, if the volume gets larger, concentration gets smaller. This formula can be rearranged in several ways. The main way it's usually rearranged is just cross-multiplying. In a proportion, the cross products have to be equal. So if I multiply this diagonal, I get C1 times V1. And I multiply this diagonal, I get C2 times V2. Those products have to be equal. By the way, this formula could also be traced back to our concentration formula, because the amount of serum before is the first concentration times the first volume. Well, that amount of serum didn't change. So second concentration times the second volume should still be the same amount of serum. This formula right here is called the change in concentration formula. Or sometimes called a concentration adjustment. And as we saw, it comes from our dilutions. It works on the same concept as our dilution. It's a form of a dilution. But it happens often enough that rather than going through the 3 or 4 steps required to do it with a dilution, it pays to just have this formula that we can go ahead and plug the numbers into and figure out. So we might ask, find the concentration of the new solution if 150 milliliters of 32% solution is diluted to 400 milliliters. Very important wording I need to point out here. If it is diluted to 400 milliliters, that is saying that we are taking it to a new total volume of 400 milliliters. If I had said we are diluting it with 400 milliliters, that would mean we are adding 400 milliliters to it. So in this case, it's the simpler of that we're just creating our new total volume is going to be 400 milliliters. So we have the starting amount, concentration of 32%, times a volume of 150 milliliters, equals our new concentration, which we don't know yet, times our new volume of 400 milliliters. And now it's just some simple algebra to solve. 0.32 times 150 is 48. And then we solve for C by dividing by the 400. 48 divided by 400, 0.12. So the new concentration is 0.12, or now this formula is very versatile. I am stuck in the habit of changing my percents to decimals before I plug them into any formula. With this formula, since there's a concentration on each side, I don't have to change it to a decimal. As long as I am consistent and do it the same on both sides. You could have done 32% times 150. Notice I just left it as 32. Equals the concentration times 400. And what would have happened there is this would be 4,800. And when I divide out that 400 here, I get 12 equals my concentration. That is already a percent. Since we left the 32 as a percent, the result we get for the concentration is a percent. So as long as we either change both of them to a decimal or keep both of them a percent, it'll work either way. It's just ingrained in me to change my percents to a decimal, so that's the way I'm normally going to do it. The main reason for that is if you're just strictly using that concentration formula, then it has to be in a decimal. So a little bit of a variation on this. Find the new volume if 120 milliliters of 42% solution is diluted to 14%. I'm going to give you guys a minute to set that up and figure it out. See if you can come up with it. So our initial concentration is the 42%. Again, you could leave it as 42, but I'm going to make it 0.42. Initial volume is 120 milliliters. Equals our new concentration is 14%, 0.14 times our new volume. Now that's V2. Usually I just drop the 2 off of it for ease of work. The reason I do that is when that 2 is there, people feel like they have to calculate with it. That 2 is not really a number. It is just a tag that says that this volume is different from that volume. So you can't calculate with that 2 at all. So we will combine 0.42 times 120 to get 50.4 equals 0.14 times V. And then, perfect, divide by 0.14, which is going to give us 160 milliliters is that new volume. Let's change things up just a little bit. Find the new concentration. If 360 milliliters of NS is combined (240 milliliters) of 45% solution. I'm going to give you a second, see what you come up with there. Key to this problem is that second volume. We have our first concentration of 45% and our first volume of 240. 45 or 0.45 times 240. We're looking for the second concentration, find the new concentration. But what is that second volume? 600, very good. We added 360 milliliters to the existing 240 milliliters. 0.45 times 240 is 108. This will be C2 times 600. And now to solve, we divide by 600. So 108 divided by 600 is 18.8, 0.18. 0.18 is a new concentration, which is 7. Questions there? Okay, it is 11:21, so it's time to take a break. So let's take 9 minutes or so, and we'll start up at 11:30.
Todd, can you hear me?
Yes.
Do you have the test in front of you, the answers?
I can grab it quick. Which problem are you looking at?
23.
23. Yep.
What do you have for an answer? Because I punched my answer into Google just to verify it. It says my answer is correct. I want to know if I'm doing something wrong.
I don't remember what your answer was on it, but most people, the mistake they make there is that they think of this as grams. It's not, it's grains. Grams would just be G. GR is grains.
Okay, yep, that's the problem then.
Okay.
How can we get those conversion charts that were on the back of the test back?
They are in your textbook. Those are just photocopied out of your textbook.
Okay. All right, well, that explains it 100% then.
Okay.
Okay.
That's almost like my way is now being like, I know it's not right, okay, I tried. Yeah.
Yeah,
Like,
it's just, that confuses me.
yeah, like, what do you mean? I tried to do them in the book. Yeah, you make this.
I tried to do the homework.
So you're busy.
There was so much homework for this too.
Yeah, like I tried, but I was like, I can't do it all.
Yeah, I see.
That's the one I was struggling with, and like the ones I circled, like, that's so no cap. Because this is the aspect you're gonna have so thank God I'm getting this class right now because it's great in pharmacology and that everybody. But like if I didn't have such signal, it happened in way too. Oh, you're starting another class? No, we're starting pharmacology. Oh, it's okay. They're just get it. Put your weight to kilogram. Concentration is rather than just great to do it at design. Like you're not supposed to do this in a half second when I'm like your time.
Yeah,
Like,
but you see, that's the thing though, like, you already know.
it's
Like, the
she
amount you
said
give to someone is.
on their way, and then it's your concentration. So maybe like in the model.
You just see that in the.
Well,
It
they
all
know.
happens in a.
They know, and they know. It's kind of you're gonna be downloading the program and you'll be fine. And I'm like, okay, because I'm not gonna lie, if I got at one point I can just do this. I just want to be able to check something. Okay, it's like right there.
I don't give up.
I saw it.
I know, it like kills me to look at it.
Yeah,
Do it,
I
and
don't know, but I'll rather save it.
And I made so many mistakes.
This is a big pencil, really.
Yeah. I know, I think it's.
I got that, I don't know.
this, like, you know, also sugar colors. But I got one and it was like, oh, like, it's so cool. It's got like, just all like. No, I'd never seen it. I'd never seen it in like the front. It was,
What's your Disney?
like,
I don't know. Which one do you connect with?
I really like.
Little Ariel? So little Ariel. You know, her waist is the size of her neck.
got no ribs. Like, what is this? I like, I don't know. So I don't know.
You know what? Sometimes I wish I could. Yeah, this would be. No. It'd be fun. How are you?
I mean, I want
didn't
to
position it. No, I didn't position it.
I just petitioned with it.
home.
You made it.
You're so bad.
Oh, it's your no.
Yeah.
What do you mean?
I always have to do something and I always go home and
This semester?
Here. Oh, look at all this homework that
I
cried
know.
I got to do about it now, and so I'll just go back home and.
And then I just have to take 2.
Yes.
So I'm just taking 3 classes. Still left at once, so all I get to do is pass it.
Oh, I was like, I thought you had to go test that. I'm like, it's really sad.
I left there.
Yeah.
Oh, I just forgot about it. Yeah, I forgot about it, guys.
I have started that.
Next to me, that's right.
Well, I'm from Chico. I don't know if you're from. So I was like, okay, well, let's see. Around, so let's do that.
Toilet, man.
But yeah, classrooms are, I like it up here so much better. The class sizes were so big down there, the teachers were so rude.
You probably need an entire
I
class.
hated
You
to
don't have
walk
to-
across the bridge.
Yeah, that too. That was brutal.
That was like the worst at like, and so,
Oh, yeah. Oh, I just slept. I'm like, my brain just.
I'm in
ain't working
advanced
anymore.
now. After the semester. There's county, for generals that
Yeah.
will go towards my PSAs on, and then I'll petition in January. Because they said it was where I don't want it to.
I mean, that's shit, like, it's
I
winter, I'm like,
Barron
it's
County,
winter.
I don't. If I consider what I can draw. I know that person.
I don't know, like.
That's cool. Because there are a lot that have. Wait,
Like my
because my blood.
Your body will do it.
2 to 3 weeks. That's
And like, it's gross, so it's maybe like. My head. My head keeps. It's like I'm not.
That's
sure
just
my
stressful.
like my food.
And like, I'm just.
Yeah.
So.
I'm just what I'm always shaking right now.
Okay, so I left a problem up here for you guys to look at if you wanted to, but we'll go through it right now. How much saline should be added to 180 milliliters of 36% solution to create a 16% solution? So we have 180 milliliters of 36%. We want 16%. You need to know what that new volume is going to be. 0.36 times 18, 64.8. Friday, so the internal calculator. Divide by 0.16 to solve. I get 405. My new volume. Now I need to have a new volume of 405 milliliters. But I'm asked how much saline should be added. What do I have to do to find the amount of saline to add? Subtract the original volume of 180 milliliters. Difference is 225 milliliters. 225 milliliters of NS. Yeah. Okay, I think we've kind of worn that formula out. It's a very handy little formula. As you can see, it saves us several steps off of going all the way back to the dilutions to do this stuff. So we've used this concept of a concentration. I want to talk a little bit about methods of calculating concentrations. Concentrations can be calculated in several different ways. One common concentration that the one that we've been using the most so far, it's called a volume in volume concentration. Abbreviation is V/V. And what it is it's exactly what our dilution is. It is the amount of serum, or the amount of concentrate, over the total solution. Of course, changing that to our percent over 100. So an example of this might be 30 milliliters of blood and 150 milliliters of solution. Volume and volume concentration thirty milliliters over 150 milliliters. We don't necessarily need the milliliters there, but I always write them in and cross them off just to make sure we have the same units on both of those measurements. And we're going to relate that to our percent, or concentration, over 100. So we will do 30 times 100 divided by 150, which gives us 20 out of 100, or a 20% ratio. Find the concentration of 40 milliliters urine with 20 milliliters of saline. How do I approach finding this concentration? Well, my concentrate, or my serum, is 40 milliliters. What goes on bottom? this. We're not given the total volume. We have to take the 40 milliliters of urine plus the 120 milliliters of saline. Get a total volume of 160 milliliters. So our ratio we're looking at is 40 to 160. Cross off the milliliters, equals blank over 100, and then we can cross multiply and divide. 40 times 100 divided by 160, 25 out of 100, or 25%. Have you guys in your notes, find the concentration. Of 400 microliters hydrogen peroxide in 2 milliliters, or not in, with 2 milliliters of So on this one, we have the 400 microliters of hydrogen peroxide. But we notice that it's mixed with 2 milliliters of saline. So I'm going to convert that to 2,000 microliters right away. So my total volume is that 2,000 microliters plus the 400 microliters. So it ends up being 400 microliters over 2,400. Now the microliters you cancel out. It's blank over 100. And if we cross multiply and divide, yes, this is going to come out to be a decimal. 16.67% or 16 2/3% if you want to do it as a fraction. Volume and volume is very convenient to calculate. There are some issues with volume and volume concentration. It's not, I mean, it is very precise if you do it correctly, but the calculation we just did here, where I added a certain amount of a substance to a certain amount of saline, isn't always accurate. I was very close here to choose the substances, make sure that they mix with saline. Hydrogen peroxide and urine both mix with saline. They're what we call additive. When you add 400 microliters of one to 2,000 microliters of the other, you do truly get 24 microliters. Not all substances are that way. We do have what's called liquid solutions. If I put rubbing alcohol in water, the volumes do not add. If I put 400 milliliters of isopropyl alcohol in 800 milliliters of water, saline solution, I will not get 1,200 milliliters of total solution. Reason being is alcohol dissolves in water. So we talked a little bit about this before. If I let the water particles be blue, water particles might be something like this, their arrangement. The alcohol particles, make them brown, actually fit in between the particles of water. Now it does push them apart a little bit. It doesn't totally add nothing to the volume, but it doesn't add up completely. So I can't say that I'm going to create, by adding 400 milliliters of alcohol to 800 milliliters of saline, I can't say that I'm going to get 1,200 milliliters of total solution. So that's a weakness of the volume in volume concentration. So another form we use is weight. Weight. Abbreviated W/W. We talked about the sloppiness of our measurements and our terminology in the last unit. In the standard system, we really use weight, our drops, our grains, and all that. The metric system, which is pretty much everything we're going to use, really the units we're using is mass. So we really should change this terminology to be mass in mass concentration. But the weight in weight was the traditional wording and we just kept it. So in a mass and mass concentration, it is the mass, or the weight of the serum, the mass or the weight, total solution. Mass is always additive. If I add 20 milligrams of something to 40 milligrams of another substance, I will always get 60 milligrams total, period. There's no loss in mass. So if we combine, now let's just say this, let's say we have 20 milligrams of alcohol in 400 milligram solution. Concentration is serum, which is the alcohol, 20 milligrams, over the total solution, 400 milligrams. Cross off the milligrams. First, equal to blank over 100, find the percent. 20 times 100 divided by 400 is 5. That's a 5% solution. I should have mentioned this on the volume and volume as well. We don't have to do the whole blank over 100 if we want to. We could have just done 200 divided by 400 is 0.05 and then convert the decimal to a percent at 5%. So the nice thing with the mass and mass or weight in weight concentration is we can combine $50 milligrams of alcohol with 150 milligrams of saline. And find the concentration. I should really specify find the weight and weight concentration. So the numbers I'm going to use here, 50 milligrams alcohol, that's my serum. What am I going to use for my total weight, total mass? 200, yes, the 50 plus the 150. So we've got 50 over 200. Going the milligrams will cancel out. If I divide that out, you get 0.25, 25%. So I might ask, how much saline should be combined with 24 milligrams of heparin to create a %8 weight in weight solution. I'll give you a minute to try to figure that one out here. This one requires us to find the total amount of the solution. We have 24 milligrams of heparin. That is the serum, so that's going to be on top. Looking for the total, that has to equal 8% or 0.08 if I put it in as a decimal. So I need to solve to figure out what this number is, total. Well, even though I put this in as 0.08, it's easiest if I make this a proportion. So that since the number I'm looking for is on the bottom of the ratio, it's easier to make it a proportion and cross multiply and divide. I've got 24 times 1 is just 24, divided by 0.08, giving us 300 milligrams total. Now that's the total solution, but we have to go back and make sure we've answered the question. Our question asks, how much saline needs to be added here? We need 300 milligrams of total solution, have 24 milligrams of serum. The amount of saline is found by subtracting 276 milligrams. Of saline. There's a third type of concentration that we use. But before I talk about it, I want to review a little bit about our metric system from last year and the link between mass and volume capacity. Remember, volume is, both volume and capacity tell us how much is contained in something, But volume comes from combining units of length. Capacity is a standard size container. Well, since the metric system was created rather than just evolved and adapted, we were able to force those units to have a relationship. In volume, we use liters. Capacity, we use liters, sorry. Volume, we use cubic meters or cubic centimeters or whatever. And in mass, we use grams. To make a relationship between volume and capacity, they created the units of a liter such that 1 milliliter was equivalent to 1 cubic centimeter. So 1 centimeter by 1 centimeter by 1 centimeter is a milliliter. Basically, a milliliter is about the size of a sugar cube. To create a link then between mass and both of those, we define the gram be the mass of 1 milliliter, or 1 cubic centimeter if you prefer to think of it that way, of water. Most of the medications we work with have densities similar to water. Density is the ratio of mass to volume. In fact, if you divide the mass by the volume, you get the density of material. Water has a density of 1 gram in 1 milliliter, or 1 gram in 1 cubic centimeter. So the density of water is literally calculated as 1 gram per cubic centimeter. What that means is if you know how many milliliters there are of water, you know how many grams there are. You can compare the two. And most of our substances that we use for medications have densities very similar to that. So remember, the relationship is between a gram and a milliliter. Very important. So one of our concentrations that we use is weight volume. W/V. And this is the weight or mass of the medication. Use the term weight even though the units we're going to give are mass. Weight of the serum in grams compared to the volume of the solution. In milliliters. Grams are related to the milliliters. Most often used when using a powdered medication into a liquid carrier, into saline, most likely. So if I ask you to find the concentration, find the weight and volume concentration of 400 milligrams of serum in an 800 milliliter solution. Now, as we look at that, that looks like a really high concentration. It's not. It's a really low concentration. 400 milligrams over 800 milliliters is the volume of the total solution. But am I going to leave that 400 milligrams? No, it has to be grams compared to milliliters. So that's actually 400 milligrams is 0.4 grams. Point 0.4 divided by 800, of course, is going to be 0.005. 0.0005 grams per milliliter. As a percent, that's 0.05%. Extremely low concentration. Of course, the reason being is I gave you that mass in milligrams. And our brain wants to connect the milligrams to the milliliters, but it's got to be the grams to milliliters. If I have concentration of 80 milligrams in 2 milliliters of solution, that sounds like a high concentration, but it is not. 80 milligrams over 2 milliliters, well, once again, 80 milligrams has to be converted to grams. How many grams is that going to be? 0.08, good. So we divide that out, 0.08, 2 is 0.04, or a 4% solution. Now, for many medications, a 4% solution is actually a high concentration. Many of our solutions are down in the 1.5% to 2% or lower. Okay, so enough messing around with concentrations. Let's move on a little bit. I have 2 small topics I want to cover before we're done here today. One, I'm just going to show you where to find it in the book. Talk about it very briefly. I'm not going to test you on it, but the terminology does come up as we're doing stuff. On page 150 in your textbook. So, a lot of vocabulary and abbreviations. These are all the abbreviations that describe how the medication is administered. IV, intravenously, the vein. IM, intramuscularly. Q4D. You know what Q4D stands for? 4 times a day. Remember, what is the one? Q6H. 6 hours. Those two are actually the same. There's 2 different ways of expressing the same thing. I'm not a medical expert, so I'm not going to go through and explain. I don't know where the Q comes from in those abbreviations, but it is something you need to be familiar with of what those abbreviations stand for, because it does make a difference. We will talk about time frames as far as medication. But Q6H and Q8H make a big difference when you're calculating a dosage. Recommendation is given on a daily amount by dividing it up for every 6 hours or every 8 hours. So our last thing we're going to talk about today, loading Shringes. This is really an exercise in reading scales. So when we're looking at a Shringe, I'll actually pull that up a little. See. Now, typically, when we look at a syringe, the first couple of numbers here, because of the tapered end, are kind of hard to read. So usually we'll go from a division that's further up the syringe to before we start looking at the markings, try to figure out how the scale is labeled. That is the first step we need to do, is we need to figure out what each division stands for. What each division represents. So if this is labeled as one, two, three, 4 milliliters. Typically, I will start at the one that's labeled number 1, just because that's a little more accurate than starting at the tip down here. And I'll go to 2. I know that represents a gap of 1 milliliter. How many divisions are between there? I count 1, 2, 3, 4, 5. Now this is obviously a center line, so I can assume there's the same number on the other side. There's 10 divisions. So 1 milliliter is divided up over 10 divisions or 10 spaces on that scale. So 1 milliliter divided by 10, tells us each division is 0.1 milliliters. Now if I fill that syringe, like that, shooting for that line, I first of all look at my scale to see what is the nearest labeled measurement. So I'm either going to go from the 4 and work up, or sorry, from the 3 and work up, or from the 4 and work down. From the 3, I know that each division is 0.1 milliliters. This is 3.1, 3.2, 3.3, 0.4, 0.5, 0.6. That's 3.6 milliliters. I could have also worked backwards from 4. This is 4, this would have been 3.9, 0.8, 0.6, or 0.7, 0.6. To the 3.6 milliliters. Not all of them are going to be labeled the same. This one might be labeled like this. So now I need to figure out what each of those divisions stands for. So I'm going from 1 to 2. 1, 2, 3, 4, 5. Now again, it's obvious that these spaces are the same. That's 5, 10, 15, 20 divisions between there. This is still a 1 milliliter gap. So 1 milliliter is now divided up over 20 divisions. Divide that out, that is 0.05 milliliters per division. So if this is filled like that, count up or down again. I'm going to go ahead and count up from the 1. This will be 0.05, 0.1, 0.15, 0.2, 0.25, 0.3, 0.35, 0.4, 0.45, 0.5, 0.55. So that's 1.55 milliliters. To be honest, when I have a 0.05, rather than counting up every single space, I know that 2 spaces combine to make 0.1. That's usually how I count it up. This is 1, 0.1, 0.2, 0.3, 0.4, 0.5, and another half is 0.55. Make sense? First thing you'll notice, this is not labeled as milliliters. It's labeled CC. What does CC stand for? cubic centimeter, or centimeter cube. So a cc is a milliliter. There is no difference. For some reason, they just choose to label some medications in cc's instead of milliliters. So here, we don't have whole milliliter gaps, or whole cc gaps, whichever way you want to look at it, but let's go from the 0.5 up to the 1. That is a 0.5 milliliter, or 0.5 cc range. And we have 1, 2, 3, 4, 5, so 5, 10, 15, 20 divisions again. If I divide that out, that's 0.025 milliliters per division. Now, to be totally frank with you, counting up by 0.025 is really not fun. Word to come back here in just a second. Or not. Start word. Seem to get about an hour and a half on a word before it has enough of me writing on the screen. So, 2-hour class is just a little bit longer than it usually tolerates. So let me label this again. So we know that that is 0.025 milliliters per division. So if I fill it, that, again, going to that marking, counting up by 0.025 is not something I want to try to do. So what I try to figure out is how many divisions does it take to make 0.1? Well, 4 divisions would be 0.1. That's 0.5, so go 4 spots, that would be 0.6. 1, 2, 3, 4, that would be 0.7. 1, 2, 3, 4, that would be 0.8. 1, 2, 3, 4, that's 0.9. 2, 5, 50, so that's 0.950 is what that is, where that is at, milliliters. Anybody have any problems reading scales? Anybody have any questions? Let's get to the meat of it. If we are ordered to administer a dosage of, well, let me label mine. So our order is for the 1.8 milliliters. Which syringe do I want to use? Top one, I'll call it syringe A or B.
I would use A.
You would use A?
Or no, B.
B?
Anyway, I
Okay.
was thinking 8 milliliters. Use A because it'd be easier to
Sure.
do.
That's actually the correct choice, B. Now, you can still do it with A, but the difference between these syringes, if this is labeled so that it can go up to 9 milliliters, it's most likely a much wider syringe. And this one, only going up to 2, is most likely a pretty narrow syringe. There's always error when you're filling a syringe. The error is the position of wherever that plunger is when you pull it back. It's right there, or is it right there? Well, in that bigger syringe, even though this distance might be the same in either one, since it's a wider syringe, that's a higher volume of medication that you're off by. Does that make sense? So in relation to the total dosage, this bigger syringe is going to have a higher percent error. So the more accurate or more precise syringe is a fuller syringe. So if this syringe is big enough to handle it, which it is, it goes to at least 1.8 milliliters. Having a syringe that is nearly full is much more precise than having a syringe that is just barely has any fluid in it. The debate comes up, well, what if this is only a 1 milliliter syringe? Should I fill it twice? It's more accurate, more precise, but do you want to stick somebody twice? We won't get into that argument. So for today, what we have covered, we have all the dilutions from last week that we covered, at page 130 to 132. That was assigned last week. We reviewed those a little bit today. Page 134, 1 through 11, the odds. Page 138, 1 through 17, the odds. Page 146, also 1 through 17, the odds. 2 more, and we're done this one. Page 153 through 154, this is not something you'll be tested on, like I said, this is the vocabulary, but it's something you should be familiar with. So on 153, 154, not graded, well, none of the homework's graded, but not going to be tested or quizzed, but you should look through all of those, 1 through 15. Then finally, page 168, 169, syringes, take a look 1 through 19 odds. Anybody have any questions? I always feel like I'm loading you guys down with homework, but it is a whole week in one class, unfortunately. You guys have a great weekend. See you next week.